right, good morning.
Hello?
Hey, we're on. All right, good morning and hello and good afternoon and good wherever you are. Good to have you back for another video. Today we are talking about combinations. But before we do, let's start with a joke. What happened when the elephant sat on the grape? Nothing. It just let out a little whine. Okay. So as we said today, we are going through combinations or combinatorics, we sometimes call them. Um, and basically, it's finding permutations and combinations of events. Now, permutations and combinations basically just means the number of different ways things can be ordered or grouped. Okay, so it's very, very closely linked with probability. And you'll find soon that it's kind of like what you use on your calculator with the C and all these like exclamation marks and all that kind of stuff. So first lesson today is, actually this one here could be a really interesting one. I want you to pause it and I want you to think, how many ways can you order one person, two people, three, four, five, and n amount of people? Have a pause, see if you can try figure it out first and see if you can find the pattern. Okay. So pause. Better be pausing. Are you pausing? Pause. All right. So I'm going to assume that you've paused. I've said pause so many times. Today, we're going to actually talk about factorial notation, and that's going to help us to actually answer that question before. So what is factorial notation? It is often used to find the number of ways we can order a set of numbers or a number of items. Now, it's also factorial notation. It is this guy here, right? So it does have a lot to do with the exclamation point. Okay. Now, if you have something like 3 factorial, it simply means that it's the same as 3 times 2 times 1. Okay. So that's what factorial does. It multiplies all the numbers after it until you reach back to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. And then 22 factorial would be 22 times 21 times 20 times, and it's going to go all the way until we go to times 3 times 2 times 1. I'm not bothered to write out all the numbers like 19, 18, 17, 16, 15, 14, 13, all the way down to 1. But that's what it is. So if we were to generalize this pattern now, if it's n factorial, we're going to start with n, whatever the number is. Oh, so we're going to start with n, I'm going to multiply it by the next number, n minus 1, the next number that's less than that, n minus 2, n minus 3, blah, 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 until we get back to times 3 times 2 times 1. Okay. So that there is factorial notation and what it is. Now, if we're talking about how many different ways we can order 3 things, that's 3 factorial, right? So technically there's essentially there's 6 ways that we can order 3 things. Okay. And if it was 5, if I was to evaluate this, then it would be 20, 60, 120. That means that there are 120 different ways we can order 5 kind of different things. Right. Now, if we think about 0, okay, so these are some helpful hints that we've got here. 0 factorial. Now, how many ways can you order nothing? Technically, there's only one way you can order it. So that's why 0 factorial is 1. Okay. So there's only one way that we can order an empty set or nothing. It's just 0. And also there's a thing called unrolling factorials, which becomes a helpful tool to us. So n factorial can be written as n times n minus 1 factorial. Okay, now let me explain what that means. I can write 10 factorial as 10 times 9 factorial. Or if I wanted to, I could go 10 times 9 times 8 times 7 factorial, because that would bring us the factorial at the end would go times 6 times 5 times 4 times 3 times 2 times 1. And so we can kind of unroll it as many as we need to make it convenient for us. Okay, so that there is that. Now, let's actually try answer some questions now, and we can see how they might actually ask us. So 8 factorial on 5 factorial is the same thing as, and I'm going to write it like this: 8 times 7 times 6 times 5 factorial all over 5 factorial. Now, the reason that I wanted to unroll the top is because now I can cancel out the 5 factorial and the 5 factorial. And this should just leave me with 8 times 7 times 6, which I don't have that on the top of my head. Yeah, definitely don't. Do I? 56 times 6, 280, 286? 286. You know what? I need to do this before it sends me crazy. 8 times 7 times 6 equals 336. Yeah, 336. Okay, so we've simplified it. Now, what if I have something like n plus 3 factorial over n plus 1 factorial? So that means this, I need you guys to actually start thinking in terms of, okay, this is a number plus 3. So if I have n plus 3 factorial, can be written as n plus 3 times n plus 2 times n plus 1 factorial all over n plus 1 factorial. So they'll end up canceling out. And then this will just leave us with n plus 3, n plus 2. And I'm happy to leave it there. That there is your simplified expression. Okay, let's keep going a little bit. 3 more. So if we've got this kind of n factorial over n minus r factorial, let's have a look here. Okay, so n factorial is going to look like this. So we're going to have n times n minus 1 times n minus 2 all the way to n minus r plus 1, and then n minus r factorial. I hope that makes a little bit of sense here. Now, that means n. So if it was 10 or some sort of number, 1 number less, 2 numbers less, and then I just want to keep going until it's kind of like n minus r, but the just before that. So I'm going to plus 1 to it. That's where the plus 1 comes from. And then after what's 1 less than that is just n minus r factorial. That'll take me all the way there. And then it'll leave me with n minus r factorial. And then again, your bottoms will cancel out, cross, cross. And that's going to leave you with n minus 1, n minus 2, all the way until n minus r plus 1. So you can see how here it gets very algebraic and very abstract very quickly. So you're going to have to think pretty deeply here. Now, if I have 1 on 4 factorial plus 1 on 5 factorial, I should have created a little bit more room for this, but that's okay. Move it over. It's the joys of an Apple iPad. Okay, now let's try explain what this is. This is 1 on 4 factorial plus, and I'm going to try rewrite these as the same or similar denominator. So I'm going to write it as, this is 5 times 4 factorial. I've just unrolled the 5 factorial. And so I can see here that if I wanted a common denominator, I would want it to be 5 times 4 factorial plus 5 times 4 factorial. And this is nice, that's just 1. But for this one here, to make it an equivalent fraction, I'd also need to times the bottom. Because I times the bottom by 5, I'll also need to times the top by 5. And here, I can see that this would just be 5 plus 1, which is 6, all over 5 factorial. Okay, now that's easier with numbers, but once we start to get into the realm of like letters, this is where it kind of starts to get a bit trickier. Again, if we take a look here, which one's technically bigger, n factorial or n plus 1 factorial? N plus 1 factorial should be bigger. So it'll be n factorial here plus, and I'm going to unroll the bigger term. So this becomes n plus 1. And then what's 1 less than that? It'll be just n. And so that'll be that. Okay, so I've just rewritten it slightly. So the reason that I do that is so I can kind of see, okay, I can see here that I've got kind of a common factor of n factorial, but one's just missing the n plus 1. So I'll go n plus 1, n factorial. And because I multiplied at the bottom, I'm also going to multiply up the top. Right, equivalent fractions, and then your other one stays the same, n plus 1, and then n factorial. So that's just going to leave me with 1. And so now I can rewrite all this. At the top, this just becomes 2n plus 2 plus 1, which becomes 2n plus 3. And then at the bottom is just n plus 1 factorial to simplify. Okay, hopefully that makes sense. New concept. Again, take your time and really think about what is n plus 1, what is n minus 3, all those questions, and then they should help you out with your exercise. So I'll catch you guys later. Hopefully that made sense, and I'll see you later. Bye-bye.